So in this section, I'm going to go over the PowerPoint slides that I posted for the class. So I've already gone over the cardiovascular system review with the crossword puzzle. For the next part, I'm going to talk about oxygen consumption and how the metabolic cart figures out how to measure oxygen consumption. I'm going to give you hints on how the metabolic cart figures it out. I'm also going to be talking about carbon dioxide transport. So this is a bit of a review here. It's using some of the equations that I gave you last day. If your heart rate was 190 beats per minute and end systolic volume was 30 milliliters, end diastolic volume 130 milliliters, and AVO2 difference of 10 milliliters of oxygen per 100 milliliters of blood. That's the extraction of oxygen as your blood flows past the muscle. Part A, what is your oxygen consumption? So for this question, you need to use an oxygen consumption equation. The equation that you need to use is oxygen consumption equals, it's your cardiac output multiplied by your AVO2 difference. Cardiac output is your heart rate times stroke volume times AVO2 difference. So that's the equation you need to use to solve this problem. In the question, I've given you your heart rate and your AVO2 difference. So all you really have to do is find your stroke volume. I've given you your end diastolic volume and end systolic volume. You can find your stroke volume by the difference between the end diastolic volume and the end systolic volume. So the stroke volume is the amount of blood that's pumped out of your heart per beat. End diastolic volume is the blood the most blood that's in your heart. And systolic volume is the amount of blood in your heart after a heartbeat. So the difference between the two is the amount of blood that's pumped out. That is your stroke volume. So in this case, your stroke volume is going to be 130 milliliters minus end systolic volume was 30 milliliters. So your stroke volume here is going to be 100 milliliters. So now you just have to plug this into the VO2 equation to solve for VO2. So VO2, your heart rate was 190 beats per minute. Multiplied by your stroke volume, which is 100 milliliters. Multiplied by your AVO2 difference, which is 10 milliliters of oxygen per 100 milliliters of blood that's delivered past the muscle. So now with this equation, you'll know you set up the equation properly if you end up with the required units for VO2. So you know your VO2 is going to be a volume per minute. So that's what we want when we solve this equation. So if you cancel out, the stroke volume is 100 milliliters per beat. So if you cancel out all your units here, the beats there, cancel out the beats there, your 100 milliliters of blood, the milliliters cancel out the milliliters of blood there. So now you're left with, you can see your units, you're going to be left with milliliters of oxygen per minute, which is what you want for VO2. So if you multiply 190 by 100 by 10 and then divide by 100, you're going to end up with 1900 milliliters per minute for your VO2. Now, in the next part, I've asked you, so that's your maximal, that's your oxygen consumption. Next part I ask, if this was maximal oxygen consumption, would you consider this individual aerobically trained? So last day I gave you some values for trained males and trained females for oxygen consumption. And you know from those values that I used the units of milliliters per kilogram minute. And a trained male would have, a maximum VO2, say above 50, that's for a young trained male. Whereas a trained female would probably have, the cutoff is probably about 45 for a trained female. So I haven't given you the kilograms for the person. I've just given you kind of that absolute, this is the absolute VO2 rather than the VO2 relative to kilograms. But if you use your thinking, if you had, say, a very, very light person, so even a person that was only, say, just over 100 pounds or about 50 kilograms, 1900 divided by 50 kilograms would give you a VO2 max of about 38. And that is, probably about average or below average aerobic fitness for a young person. This would be a good VO2 max for, say, a 70 or 80-year-old, but it's not that good of a VO2 max. Say for a female, it would be about average. For males, it's probably a little bit below average for a young male. So I would say that the individual was not very aerobically trained. So I picked just a light body weight here, because if you even picked that's 100 pounds is quite light. If you went even heavier, that number would come down. So you know for sure that the person's not aerobically trained. So if you picked like 70 kilograms, this number would be even lower. And the last question asks, what is the ejection fraction? So here I'm just asking you to use a different equation. So again, going back to the whiteboard, ejection fraction is equal to your stroke volume multiplied by your end diastolic volume times 100. If you plug in those numbers, you get 100 divided by 130 times 100 equals about 76.9% would be your ejection fraction.